Numeracy in today's world. First objective, use a calculator for routine mathematical operations. Let's look at a definition. Definition: four function calculators. A calculator that performs the operations of arithmetic, add, subtract, multiply, and divide, and a few other functions. These types of calculators are pretty much your most basic calculator out there. The next step of a calculator would be considered a scientific calculator. And then beyond that, you have the more expensive calculators which can graph and do some high-level mathematics. Example: calculating a sum that involves a pattern. In the September 26, 1966 show, Lucy the Bean Queen, Lucy learned a lesson about saving money. Mr. Mooney had refused to lend her $1,500 to buy furniture because he claimed she did not know the value of money. He explained to her that if she were to save so that she would have 1 penny on day 1, 2 pennies on day 2, 4 pennies on day 3, and so on, she would have more than enough money to buy her furniture after only 19 days. Use a calculator to verify this fact. So again, let's take a look at the situation. Mr. Mooney claims that if she would have 1 penny on day 1, 2 pennies on day 2, 4 pennies on day 3, and to continue this trend, by the 19th day she should have more than enough money, meaning more than $1,500, to buy her furniture. Well, what is the pattern? We're taking the original amount of money, the day 1 money, and we are doubling it, multiplying it by 2, multiplying it by 2, multiplying by 2, multiply by 2, multiply by 2. So let's use a four-function calculator to see if this premise of having enough money holds true. And as you can see on the chart, by the time we get to the 19th day, we should have enough money to buy the furniture. But let's go ahead and try this on a calculator. So here's my standard four-function calculator. So let's start with a penny, or 0.01, and now let's double this amount of money for 19 days. So on the first day we have a penny times 2, so there's 2 cents on the second day, times 2, 4 cents on the third day, and we will do this for 19 days. So here we are, third day, day 3, day 4, 5, 6, day 7, day 8, day 9, day 10, day 11, day 12, day 13, day 14, day 15, day 16, day 17, day 18, and on day 19, $2,621.44, which is enough to buy the furniture. Objective: use estimation techniques. Example: estimating an appropriate number of birdhouses. A birdhouse for swallows can accommodate up to 8 nests. How many birdhouses would be necessary to accommodate 58 nests? So we need to take 58 and divide it by 8. And we see that 58 divided by 8 is exactly 7.25. Meaning if we have 58 nests and one birdhouse accommodates 8 nests, then 58 divided by 8 is telling us we need exactly 7.25 birdhouses. But my problem is we cannot buy a fractional part of a birdhouse. So here's where we have to decide to either round up or round down. If we round downward to 7 birdhouses, 7 times 8 is 56. That does not accommodate 58. So here's a case where we have to round up and say we need approximately 8 birdhouses. We round up and say 8 birdhouses is the number needed to accommodate 58 nests. Objective: interpret information by reading circle, bar, and line graphs. Definition: circle graph, also known as a pie chart, a circle is used to indicate the total of all the data categories represented. Let's look at an example. Interpreting information in a circle graph. In a recent month, there were about 2,100 million, which is the same as 2.1 billion, Internet users worldwide. The circle graph shows the approximate shares of these users living in various regions of the world. Using the graph, let's answer A through C. Part A, which region had the largest share of Internet users? What was that share? B, estimate the number of Internet users in North America. And C, how many actual Internet users were there in North America? So let's start with Part A. Part A is asking which region had the largest share of Internet users. And what was that share? Well, looking at the pie chart, we see that the largest percentage happens in Asia. So the answer to letter A, which region had the largest share of Internet users? That answer would be Asia. And they had 44% of the share of Internet users. Part B, estimate the number of Internet users in North America. So again, looking at the pie chart, we see that North America had 13%. Now we're being asked to estimate. So you want to come up with numbers where it's easy to do arithmetic with, or you could use your calculator as well. But 13%, if we were to round that down, we're about 10%, roughly 10%. So if we take 10% of 2,100 million, again, we're going to take 10%, 0.1, times 2,100 million. Again, our answer will be in terms of millions. 10% of 2,100 is 210. So we can say that it's about 210 million users in North America. Now again, that's approximation. This estimation underestimates the true value. Why? Because we rounded 13% downward to 10%. So again, this is an approximation. Letter C, how many actual Internet users were there in North America? Well, now we'll take the true percentage, 13%, which is 0.13, and multiply that by 2,100. And 0.13 times 2,100 million, again the 2,100 is in millions of people, we multiply this out, we get 273, and again that the units would be millions of people. So the true actual number of users in North America, 273 million. Let's take a look at a bar graph. Interpreting information in a bar graph. The bar graph shows annual per capita spending on healthcare in the United States for the years 2004 through 2009. A, in what years was per capita healthcare spending greater than $7,000? B, estimate per capita healthcare spending in 2004 and 2008. And C, describe the change in per capita spending as the years progressed. Let's start with Part A. Again, the question asks, in what years was per capita healthcare spending greater than $7,000? So looking at the bar graph, let's try to find on the vertical axis about where $7,000 is, which is right here. And do we have any rectangles or bars extending over the $7,000 mark? And as we can see, these last three, 2007 through 2009, all have a height greater than the $7,000 mark. So yes, the answer to A is that happened in 2007 through 2009. Part B. Estimate per capita health care spending in 2004 and in 2008. So looking at the 2004 bar, we can see again estimation about where is that bar, and we can see that that's at the $6,000 mark. So in 2004 we're estimating about $6,000. What about the year 2008? Again, we'll go up to the bar 2008, and we're seeing it's right about here. So it looks to be a little bit more than halfway between 7,000 and 7,500. So that's 7,250. So we're a little bit more than that. So a good estimation would be $7,300. Part C, describe the change in per capita spending as the years progressed. So starting with our first bar, 2004, we said that was about $6,000. Look at the very end, 2009, we can see that bar is about $7,500. And notice that the bars increase steadily, slowly from left to right. So a conclusion for C, you could say that as the years progressed, per capita spending on healthcare increased steadily from about $6,000 in 2004 to about $7,500 in 2009. Objective: use writing skills to convey information about mathematics. Definition: journal. What is a journal? Informal writings in which the student's thoughts are allowed to roam freely. Learning logs. More formal entries such as a specific question posed by an instructor. Example: writing an answer to a conceptual exercise. Discuss the differences between inductive and deductive reasoning. Give an example of each. Write a short paragraph to answer this exercise. Here is a possible student response. Deductive reasoning occurs when you go from general ideas to specific ones. For example, I know that I can multiply both sides of 1/2 x equals 6 by 2 to get x equals 12, because I can multiply both sides of an equation by anything that I want except 0. Inductive reasoning goes the other way. If I have a general conclusion from specific observations, that's inductive reasoning. Example: in the numbers 4, 8, 12, 16, and so on, I can conclude that the next number is 20, since I always add 4 to get the next number.